static. Well, you cannot use this anymore. I'll call this, for example, discount 2, whatever. Okay? When you make a method static, you see I'm making a method static, right?
Yeah.
I'm saying you can call this method without the need of having an object existing first. Normally that's not true, right? Normally when we want to call a method from a class, we have to have an object of that class, right? Otherwise, from where we invoke it, right? But when the method is static, you're saying the method does not need an object to be invoked. You can call it directly from the class because there is one method for everybody. Got it? So here, all I do is write the class name and then set discount. Got it? Yes?
Yep.
Now, having a method being called directly from a class, like I'm doing there, doesn't that sound familiar to you?
Yeah.
Where have you seen that before?
Math.com.
Math.pow, for example, when you want to call the power, right? You say math.pow. That method pow is a method from the class math, and it's called without having, you don't have to say new math, right? Correct? What else? What else? No. The main static method, yeah, okay, before we get there. What else? Come on guys, you surprised me.
J-option paint.
J-option paint that show message dialog or show input dialog, right? Do you have to say new J-option paint? You call the method directly, right? System outprint, right? Do you have to say new system?
No.
What about integer parse int?
Yes.
Do you have to say new integer to call parse int? No, right?
No.
That method is static. That's why if you remember when I explained how the wrapper class integer looked like and I put parse int, I put like a little star and said here we have to add something. That means static. Because that method is static. You don't have to say new integer to be able to call parse int. You can call parse int whenever you want. Whenever you want to convert a string into an integer, you call parse int directly from the class. Right? So this is nothing new. We have been using it already. Double parse double, float that parse float, etc. etc. Got it?
Do you still have to leave the static and the constructor?
Good question. Professor, if it doesn't really matter from which object I call it, you have to realize that, right? It doesn't really matter from which object I call it, right? It's kind of stupid to keep it in the constructor. Why? Because every time a new guy comes in, he's going to be affecting the rest. And that's maybe that's something we don't want. Normally, if you want to declare something static, you want to set it up once, and that's it. Right? Why have to set it up every time? Got it? So normally, you should not receive that to construct the object. For example, you should have your constructor just with two parameters, like this. Here, you shouldn't receive the discount. Is that clear? Now?
No.
Who said no? Okay. The constructor is normally a method that is called for every instance, right? Correct? Now we're saying that when a variable is static, when an attribute is static, it doesn't really matter if you call it from this object, from that object, because it's the same for everybody. Correct? So why would I go through the hassle of every time I create an object, be changing the discount? That would be stupid because all of them are going to have the same, right? So let's not set up the discount when creating the object. If you want to set up a discount at any point, call your static method set discount, and that's it. Got it? So what you can do, hold on one second, guys. What you can do is you create your objects, and if you want to put a discount before creating them, go ahead and do it. You can do that. Item set discount, say 0.5. So you say all of them are going to be 5. Today, for example, the discount is 50% off. You put a discount and you create your objects, for example. Now all of them have 50%.
But then you have to do it to every single one, every single item.
Not anymore. Remember, the attribute is static, right? When I do that first line that says item that's a discount 0.5, I'm saying for all the objects of this class, all of them are going to have 50%.
I know, that class, so let's say you have another, like, let's say you have toys. And is that gonna be also 0.5 too?
No, because that's per class. If I want to have a class toy, like you call it, and I want the discount to be static, I'll have to put a static attribute in there as well.
Okay.
But when I say item that's a discount 0.5, I'm saying is no matter how many objects you create from this class item, all of them should have 50% now. Somebody else got a question? Yeah.
If, when doing it this way, then we lose the ability to individually discount, say, the PS3.
Correct, we lose the ability to do that. So what do stores normally do? Stores normally have two discounts. Individual discount or single discount and general discount. So if we wanted to have that flexibility, we would have to go to our class item and have discount 1, discount 2. One of them static and one of them instance, for example. Got it?
And then you drop everything else in there?
Hold on, one at a time. Okay, you finish and then I'll go with him. Yes.
But at the very top, we made it static in the item class.
Uh-huh. Yeah.
Right. Private static double discount. If you remove its static
Uh-huh.
and keep the public static void discount down there, would it cause a problem?
Yes, because you would cause a problem because that static method would be wrong because you don't have a static attribute there to change. When a static method is supposed to be called without the need of an object, right? So that it's the same for everybody, right? So if I delete the static there, now that means that each item has their own specific discount. So how could I call set discount for everybody if each of them have their own? Make sense? Then you're contradicting yourself. That's wrong. It's a mistake. Yes, sir.
You have a question, please?
Okay, go ahead, sir.
I was gonna ask you, why is it they usually make a constant like final equals static?
Okay, when you create constants, we have that constants in the last class, right? When you say public, static, final, right? Okay, we make it static because a constant is supposed to be a constant. A constant is supposed not to change, and a constant is supposed to be the same for everybody. Right? Otherwise, you will have a constant for one class, a constant for another class. That's kind of stupid. You understand what I'm saying?
Yeah.
Or if you don't put a static, then that means that when he creates an object, he has his constant. When she creates an object, she has her constant. You understand what I'm saying?
Right. So
You're wasting memory, and that's not right, right? If all of them are objects of the class, for example, that class we did what? Board, right? If I'm going to have, for example, 3 boards, and I'm going to have a constant, then all of them should have the same, right? If I'm going to make, for example, a class ball, right? The like soccer ball, or whatever you want to call it, and I want to have a constant like pi, because all of them have circular shape, then all of them should have the same pi. It doesn't make sense that for his ball, pi is 3.14, for her ball is 3.7. It doesn't make sense, you know? So that's why we put a static there.
So any constant.
Always static because it's supposed to be shared. That's the reason. Some people just tell the students, oh, it's because the book says so. No, there's a reason
I've
why
seen
we
it,
put
but
it.
I didn't know exactly.
Exactly. Normally you see that you don't understand why. The final, you understand why the final though, right? Okay. Yes, sir.
You said when you create the classes, as long as you're putting them inside each one, and you're, like class 1, you said discount 1, I get discount 2.
Hold on 1 second. Use your wording carefully. You're saying your classes or objects. What do you mean?
Your object, sorry.
Okay, when I create my objects, what?
And you have a discount of 1, discount 2, like you're saying in other stores.
Okay. I'm saying if I want to have 2 discounts, like, because you told me, if you do it like this, then all of them have the same discount. There is no individual discount for all of them. So I told him, in that case, your class item, having name, price, right? Correct? Would have to have, for example, single discount, and one, say, total discount, or whatever you want to call it. This guy would be the static. And this guy wouldn't. You understand what I'm saying?
So the total discount will have the static.
Correct.
Okay.
And that's true, because sometimes, I don't, let's say, sorry?
How would you keep the static from overriding?
Actually, you don't want them to be right. They come together. This is what happens when you go, for example, to Lowe's. Okay, all of you have been to Lowe's or Home Depot, right? Sometimes do you see that they say something like 10% on all high efficiency electronics, right? That's what it says, right? So it doesn't matter if he buys Samsung, she buys GE, whatever. As long as both are, that's static. Exactly, that's static. Very good. But now, if their link chooses, for example, a GE refrigerator, okay?
That's not.
Exactly, that has 200 off of this specific model, then she'll get the 200 off plus the generic 10% off for everybody. You understand what I'm saying? That's why we have to discount. Got it? That's the idea. Is that clear, guys?
Yeah.
So
Yes.
it's a discount from that one and from the 10% off the
Correct.
overall.
Correct. Yes.
What if the discount and the individual is less than the overall discount. So let's say it's 5% and the overall discount for everything is 10%, but they don't want the overall to apply to that specific item. They just want the individual discount that they're applying to that item, to that item.
Remember, what you're saying is, at the end of the day, regardless of how I do things, I should have a method calculate price. Right? I should have a method here calculate price. Roughly, it would be the total price times 1 minus discount. Roughly, right? Now, if you want to do, what you're saying is pretty much store policies. Some stores some stores are picky and say, you know, if there are 2 discounts like the one I mentioned here, I'll give her the highest discount only. So you can make validation, say, if this is bigger than this, only apply 1. If I want to be more generous, I can simply make the math and apply both. So that's just the logic of calculating the final price.
So you have to for that individual item?
Correct.
And the sales price for that particular.
Correct. You have to validate there. Okay? That's more of logic in the actual calculation of the price. You want to learn some little math, or do you like math, guys? A little bit? Okay. No? You don't want to learn? This is useful for your finances. This is useful for your finances. If you don't want to learn, that's fine. Okay. If I tell you you're going to have 30% off, okay? And then say 40% off. And somebody tells you, I'm going to give you 65% off. Just one discount. Which one is better? Which one is better? Which one is better? Lisa, what is it? Work.
70%.
How many people vote for left?
65.
So this adds more, 70? People say this is worse?
65 is better.
Oh, you think so?
40 off the already 30.
That's not necessarily true.
Why?
If your item is $1,000 and you get 30% off, so you have $400.
And then it's
700
from
you're
that.
paid, right?
Yeah.
Then you apply 40% off is 280, right? 70 minus 280 is how much? 420, right?
And the other one more.
Alright?
Yeah.
Okay. But if you have 65% off,
Yeah, you get more.
that means 650 less, right?
Wait, 350.
So, yeah, in this case it's...
No,
but
350.
Actually, let me put it this way.
Is it 350?
Let me put it this way.
You subtracted wrong.
Closer.
You subtracted wrong. It's 350, isn't it?
I put 65, should be 350.
Yeah.
That's fine.
But you put 450 down there.
My bad.
So you get more.
My bad. Yes, thank you very much.
So that's why it's better to have that
So
individual.
you see, that's what I want to get. This seems to be a smaller discount, right? Right? It seems to be a smaller discount, right? 65. Normally you rate you just add this up, right? And then it's better, right? 5% off, better, right? But remember, 30% is applied on the total,
Yeah.
but then 40% is applied on a smaller amount,
It's in the fine print,
right?
so they don't tell you.
So you get screwed, right? That's what they do all the time. Remember, this was one of the things that happened to me once when I wanted to buy a car.
An additional 20%.
Yeah, I wanted to buy a car, but it's something expensive. And there were 2 stores, and one store was saying, oh, you know what, the other store is giving you, I was talking to one of the salesmen, and he told me, the other store is giving you, like, for example, 10% off, we're going to give you 7 and then 5. 12, right?
So,
And I told him, okay, I'll go with you if you give me 12 straight. Yeah, it's the same thing. Okay, then give me 12. People give me 12 thinking it's the same. It's stupid, it's not the same. Yeah, that's the thing, many people don't know math. This is simple math, right? And this is more obvious as the number grows bigger and bigger. If you're talking about a mortgage or a house, for example, and this is important with interests.
Yeah, why else would they split it up instead
Yeah.
of just giving you 12?
Yeah. They split up because the people that split up
Yeah,
are the
they
people that are
want you.
smart.
Exactly.
And they want to fool you. But sometimes the salesmen don't know that. They think it's the same. So yeah, it's the same. Oh, but they make you send 12% and you're happy, right? You just laugh on their faces because this is simple math. Some of you did not want to learn that, so if you didn't want to learn that, forget it. The ones that want to learn it, remember it, okay? So it's good, right? This is not Java, this is just simple logic, okay? Thank you very much. I was doing a row subtraction, otherwise it was looking weird to me.
Yeah.
Okay. Anyway. So, if we want to make, let me do whatever I was telling you before. Normally you want to make this with 2 discounts, I told you, right? Price discount, that's not a problem, right? I'm just trying to finalize this code so that you guys see the difference between static and instance. So here, then here, when I create my object, I have to specify what's their single discount, right? Like 0.1, then here 0.2 maybe, here maybe 0. I don't want to put any discount to the PSP, whatever, right? Now, this is something I was talking to the guy, to you, what's your name, sir?
Al.
Sorry? Al?
Al.
You're Al Gilmore, right? Okay, I was talking to Al, and Al was saying, what about if the store doesn't want to apply two discounts, or if one is bigger than the other? So I'm just going to go with one simple policy. Imagine that the store policy is very straightforward and says, you know what, I will apply as many discounts as possible. Now, obviously, this also matters. Which discount should be applied first, right? Correct? So the store policy might say, I will apply first, say the single discount and then the total discount. Or maybe the opposite. Doesn't really matter. For us, what is better? That the biggest discount is applied first, right? As a customer, we would like that, right?
Right.
But the system works one way only. So let's assume the system works with single discount first and then total discount. Got it?
Mhm.
So public double calculate final price, right? So it will be something like this, right? Double here final price will be what? 1 minus the static discount, right? Times 1 minus the single discount, and all these times price, right? You understand why you want 1 minus, right?
Yeah.
All of you understand why 1 minus? No? Okay, figure it out then. I'm kidding, guys, I'm gonna tell you. Make a mistake. And then here, return. I will tell you why I'm saying 1 minus, okay? Don't worry, guys. If I tell you 20% off, if I tell you that your discount is 20%, then how much do you pay? 80%. Is that clear? Is that clear with everybody?
Yeah.
This is another typical mistake from people. This is math, okay? Again, it's funny. It's extremely funny. I love it. When I go to the store, and it says 25% off, and people want to calculate what the final price is, they start saying, oh, 25% off. They calculate 25% of the whole price, and then whatever they get, they take the big number, the total price, and make minus that. How many people do that here? You want to raise your hand? I'm sure half of you do that. I'm sure half of you at least do that. You know, like, why the heck do you have to do two operations? If it's 25% off, you're paying 75%. Multiply 75% times the price. That's it. Right?
All
I was
right.
talking to one sales lady once, and she said, oh, you're a genius. I'm like, really? That's surprising. It's fun. So, they say, in the land of the blind man, the one-eyed guy is the king, right?
Yeah.
Something like that, right? So, okay. So, that's the thing. If I tell you 20% discount, then 20% is 0.2, right? So how much do you pay? 1 minus that, 0.8. Now you understand why we say 1 minus? All of you guys? One is equivalent to say 100%, right? So we're doing everything in the decimals already, so I'm just doing it like that. Is that clear with everybody? 20%, if that's your discount, you pay 80%. Because we're considering 100 as a total, right? If we're putting 0.2, that means that the total is 1, right? Correct? If I'm saying that your discount is 20%, then what you pay is 80%, right? 100 minus 20, right? But if I don't tell you this way, if I tell you your discount is 0.2, I'm putting now the 20% in 0.2 as a decimal. What will be your total? You can no longer say your total is 100. Your total now should be 1, right? So you pay 1 minus that, that's what you pay, 0.8, 80%. Got it? That's why it says 1 minus 1 minus. Is that clear? Yes? You just have to remember this, guys. You have to remember this simple math. This symbol means that you're dividing over 100, right? If you say 20%, it's equal to say 20 over 100, right? You make the division, this is 0.2, right? You have to always remember that. That's a simple conversion. We are symbols represent 1 over 100, right? Okay? Remember that, guys? An apple and another apple, right? And ask once in class, if I have 4 oranges and I want to give it to 2 kids, what do I do? And people tell me, you make juice. They're very smart sometimes. I asked what's 2 times 1 and they told me a good deal. Okay. Is that clear, guys? So now we have the calculated final price. I'm making it straightforward. So pretty much the way I'm calculating the final price is I'm applying the single discount first, and then on top of that, I'm applying the total discount, right? So if I want to know what my final price is for a specific item, so I say final price. Now everything is on 70%, right? Correct? I said everybody's 50%, and then I said 70%, right? Let me put a number that we can easily make the math. Say 1,000. Okay? To do things fast. So final price for item 1, for example. IT1, or calculate. Okay. What should the final price for item 1 be? We said that the final price is going to be, first we apply the individual discount, so 10%. So the first discount will be $900, right? On top of that, we're going to apply the total discount that is 70%. So 70% of $900. So we're going to pay only 30% of $900, which is, yes, 270, right? Okay. To get fast, guys. Okay, 270.00, these decimals are garbage. 270. Got it? Yes?
Got it.
So we're applying things correctly, right? Is that clear?
Yes.
Now, do you understand the difference between static and instance?
Yep.
Did you know that from Java 1? You were supposed to learn that in Java 1. You have to understand the difference between them. Extremely important. That's a normal question in job interviews. Job interviews, because I also interviewed back in the day, simple. What's the difference between a class and an object? Classic one. It's getting old. The other one is, what's the difference between a static versus an instance attribute or method? And people are like, the static doesn't change, and they start making up, right? So you have to understand that. Okay, guys? Make sense?
Yep.
Okay. Let me see if I have. I'll give you 5 minutes to solve a problem using static attributes. Okay. If you cannot do it in 5 minutes, then by 7:06, right? By 7:15, I'll solve it. Okay. Non-objects. Oh, I didn't tell it. Doesn't really matter. We want to look at